All right, so we have our next little example here. Limit as x goes to 6. However, notice, this is limit x goes to 6 only from the left of this function. This is rather like the boss comes down and says, I have a little issue I need you to work out for me, and you offer to work this entire problem, this entire process, and the boss says, no, I just need this little bit. We're not asked to find the whole pie. We just need this one little piece of it. All we're asked is to investigate if x approaches 6 from the left. Now, the restricted approach, the one-hand limits, they work the same way. Always substitute and simplify. If you substitute, simplify, and get an answer as a number, you're done. It's that number. If you substitute and simplify and get 0 divided by 0, do some algebra or trigonometry, simplify and try again. If you're doing a one-sided limit, the procedure is exactly the same. However, except here, if I'm approaching 6, if we substitute, and in this case we get 6, and remember, we're not substituting negative 6, we're approaching positive 6 from the left through values that are less than 6. So if we substitute 6 minus 10, that's negative 4. 6 minus 6 is 0. So substitution gives 6 minus 10 over 6 minus 6. This is negative 4 over 0. This is non-zero over 0. This is the special case. But the difference here is we don't need to do the left approach and also the right approach, because we're not asked to be concerned about the approach from the right-hand direction. All we need is leave this alone. Just do the left approach. So as we approach this value from the left, in this special case scenario, we choose x equal our 5.9, that's my 1/10, but we don't need 6.1 because we don't care what's happening at 6.1 because nobody asked that question. When you're asked a question, you don't need to give, 5 pages of result above and beyond the answer. All we're asking is this question: what's the limit as x approaches 6 from the left? Well, find that and you're done. And so all we need in this scenario is only the left-hand approach, 5.9. We don't need the 6.1. You could find it, that's wonderful, but it doesn't have anything to do with what we're talking about. So 5.6, now we go through the same process. So 5.9 minus 10 over 5.9 minus 6. Again, we don't care about the specific number. All we need is 5.9 minus 10 is negative something. 5.9 minus 6 is also negative something, but negative divided by negative is positive. And so what we can conclude then is the limit as x approaches 6 from the left of this function is equal to positive infinity. And there's nothing else to do because we're done. This is it. So if you're asked to evaluate a left-hand limit or a right-hand limit only, the procedure is identical. It's identical to the unrestricted approach. However, you only need to do the approach from that direction. Always try direct substitution. If it works, fine. Look, if we have the limit as x approaches 1 from the right of just some polynomial, x squared minus 4x plus 3, substitute, simplify, you're done. This is 1 squared minus 4 times 1 plus 3. This is 1 minus 4 plus 3. That's equal to 0, and you're out. You're done. There's nothing to do. If you're asked the limit as x approaches pi from the left of sine of x over x plus 1. That's just fine. Substitute, simplify, and try again. Here we go. Just substitute, simplify, because what we generate here, this is sine of pi over pi plus 1. Sine of pi is 0. Pi plus 1 is pi plus 1. 0 divided by any non-zero value is 0. We're out. We're done. There's nothing more. Even if it's a fraction function. Even if it's the limit as x goes to 5 of x minus 6 over x plus, I don't care, 3. It doesn't matter what we have here. Direct substitution is always the first. We're approaching 5 from the left. Suppose we're approaching 5 from the left of this function. Substitute, simplify. This is 5 minus 6. It's not negative 5. It's approaching 5 from the left. Over 5 plus 3, that's whatever that is. That's negative 1 over 8, and you're done. So if direct substitution gives you a result, that's wonderful. If it doesn't, then you proceed along the process we've already discussed. Suppose we want the limit as x approaches 2 from the right of x minus 2 over x squared minus 4. Direct substitution. Direct substitution gives you 0 over, we know what to do with 0 over 0, right? Direct substitution gives you 0 divided by 0. Do some algebra, simplify, try again. So that's exactly the process you go. It doesn't matter if you're only doing from one direction. The procedure is the same. This is equal to the limit as x approaches 2 from the right of x minus 2 over factor, reduce, try again. Now substitute, this is 1 over 4, and we're out. And so the one direction approach is done precisely the same as the unrestricted approach. Except, if we're in this special scenario, we only need to do whichever direction we're interested in. And if we're in some piecewise function, we only use the direction we're interested in. So that's the process for this. This is the process for this special case. And then in any other scenario, the procedure is the same as the unrestricted approach.